Let's take a minute or two to talk about what a topographic profile is before we get to the instructional piece. A topographic profile is just the side view expression of what an area might look like. So if you have a hill, you would know that a hill goes up and then it goes down. So if you were to trace out with your fingers, you would do something like this. We think about the same thing in our profile, right? If I turn to the side, someone's profile is just that outline from a side view. So a topographic profile is just trying to get an idea of the highs and lows that you run across in a given area. So if we turn our attention to the map here, you're going to see that we have a topographic map with our contours here. And there's a couple things about this map we want to pay attention to. The first thing is the scale. It's 1 to 24,000 scale, which means that 1 inch on this map would be 24,000 inches in real life, or 1 foot on this map would be 24,000 feet in real life. So that's how that ratio scale works that we learned about in class. We also see the contour interval is 20 feet here. And so right away I would say, okay, I see this 1,200 foot mark. And then if I count the lines up, I'd be 1220, 1240, 1260, 1280. That would get me to 1,300. And then we would go on to there and get up to 1,400. So from this I can tell that my contour interval is, again, 20 feet. And my index contour interval is 100 feet. So 100 feet between these thicker lines. Now we also want to notice that there is a line across here. This is A, the letter A, and across there it's A prime. So a little tick mark we call A prime. Now this line represents this stretch of land that we want to draw our topographic profile across. So you may remember from class that when you have enclosed circles like this, that's going to be a hill. So across this section, we're going to expect it to go up and then back down again. But now we need to talk about exactly how to do that in more detail. And so that's what this next section is going to cover. One more quick thing, I also wanted to point out what's going on down here in the lower half of this graphic. So the top half is the topographic map. The bottom is just graph paper, and what it's representing is distance across the bottom. So you can picture yourself walking across the bottom, and you're going to eventually be going up and down over this landscape. So if it was just one big hill, it might go up and down like that. But as you can see here, we're going to be going up and down a couple different times, which we'll get to in a second. On the y-axis, so this vertical axis here, it's labeled elevation in feet. And so each of these little boxes is going to represent a certain amount in feet that you're increasing or decreasing as you're traveling across the landscape. So this is just the place that we're going to draw our profile. Now let's get started. The first thing we need to do is to label the y-axis with the proper elevations. So if I look, I notice that my line A to A prime is going to fall up to 1,400 feet. That's the highest I'm really seeing it go. And then down here, I'm definitely going past the 1,100 feet mark. So what I'm going to do is mark this at 1,100 feet. Now I do notice I don't get down to the 1,000, right? If I did, I'd want to make sure that I'm labeling this correctly. And what I'm going to choose is I'm going to say I need to get to 1,400 feet. So if I made this 1,100, 1,200, 1,300, I wouldn't have enough space here. So I need to make each thick line 100 feet. So 1,100, this will be 1,200, this will be 1,300, this will be 1,400, this will be 1,500. Probably won't get to that 1,500 mark, but at least I have it there if I need it. And so now when I look at this, I realize that I've got 1, 2, 3, 4, 5 spaces in between the 1,100 and 1,200 foot mark, which means that each of these blocks is worth 20 feet. So I might make a little notation here that this is 20 feet, just to keep that in mind. Now that I've figured out my y-axis labels, I'm going to take a piece of paper and place it along the A to A prime line. And I'm going to mark A to A prime. And I'm going to first start by marking all of the thick or index contour lines. So this one right here, this A line, actually starts on this dark line here, which is 1,200. So down here I might write 1,200. The next one here, we go 1,200, 1,300, 1,400. So this would be the 1,300 line. So I mark that. I'm going to come here. This is 1400. Oops. There we go, 1300. This one is also 1400. I'll notice that here, if I come off of that, these are two hills that we've talked about, these enclosed circles. So this goes up from 1300 once again to 1400. So I'll put my line back and mark 1400 and 1400. Gets a little squishy, that's okay. Then I'm going downhill, so I'm back on this 1300 foot line. So I'm going to write 1300. Now I'm on the 1200 foot line. And then I'm going to be on the 1100, so I can actually follow that all the way around. So now I'm popping out to 1100. And let's see what happens over here. So there it is, labeled 1100. Well, I know that I don't keep going down because I've got these lines that are creating what are going to be little valleys, the little V shape that we've talked about before. So while I'm going downhill to here, I actually go back uphill to this line here. And another way to look at that is I can see that I'm picking up this 1200. You can barely read it, but it's there, which means that this must be 1100 feet. So I'm going to put that line back. And here's another 1100, and then another 1100. And one of the things I like to do is to notate, am I going up or down as I move left to right across this line? So here we know we go from 1200 to 1300 to 1400. So I'm going up here, I'm going up here, and then I'm at the 1400. Well, I'm at 1400 over here, so we know from learning about how hills are represented by these enclosures, this has got to be a little hilltop. So what I like to do on my line is to make a little symbol like this, indicating that it's a hilltop. And then I'm coming back over here to see I go from 1400 to 1400, but I go down and then back up again. So that's called a saddle. It looks just like a horse's saddle in real life. And so I'm going to put a little scoop, like a little horse's saddle. And then I'm on the top of the hill again, so I'm going to make a little arch there. And then if I look, I know I go from 14 to 13 to 12, so I'm starting to go back down again. So I'm going to write little down arrows. Down, down. Between 1200 to 1100 would be down again. And then this is where things go from 1100 to 1100. And so we know from looking at this downward pattern that we would be going down and then back up again. So this is going to be another one of those saddles. So I would draw a little saddle shape. And then here is a hilltop again, which once again, it's not enclosed, but we can see that that little shape there is indicating a little ridge. So I've got my little hilltop. And then coming off of that, I would go back down again because I'm heading toward lower elevation. So I'm going to do a little down there. Okay. So the last step is to draw in the little tiny, the smaller contours in between. So I would just do like a really quick job there. It doesn't have to be perfect, but we just want to see that these are really spaced close together. This is going to be further apart, so we know it's steeper and then more gentle there. And then I pick up a few more in here and a few more in here. And I'm going to pick up a few more in there and do that all the way across. So like I said, it doesn't have to be exactly perfect, you just want to get it in about the right spot. Now, a few spots come to attention here, and that's that I've got this little saddle in here. And so I want to know which of these little marks are going down and which of them are going up. And so I can see, if I pull my paper back, that these first three are heading down, then I go into this flat spot, and then they go back up again. So I might want to indicate that these are going down and that these are going up. So a little notation on there might be helpful. And the same thing is true over on this side. We have these two are going down, and then these two are going up. So that might be a little notation that will be helpful for you as well. So I've gathered all of the information. So now what I'm going to do is I want to draw the actual profile. So I'm going to slide this up and we're going to place the A prime line right along here. And so I can make that little notation if that helps me later. So I would say this is the A mark, and then I'm going all the way to about here. It's going to be my A prime line. Not necessary, but kind of helpful for me to look at that. And so as I place that there, I'm going to start by doing my index contour lines. So this is 1200, so I would come up here and put a dot at 1200. Then this is going to be 1300, so I want to come in about here for 1300. And then I'm going to go 1400 is here. I've got another 1400 about here. I've got another 1400 here. Another 1400 here. It's a quick little one. And then I've got my 1300 sits about here. My 1200 sits about here. My 1100 is coming back down to here. My another 1100 is in here. Another 1100 in here, and then I go off of the profile there. So I can see my overall shape is going to do something like this, but not quite sure. So these little detailed marks are going to help me. So one of the things you can do is you can slide this up into here. It might make it a little easier to see. And so these are pretty evenly spaced, but if I go this first little tick, remember it's a contour interval of 20 feet, we see that here. So this next little line is going to be 1220. And we said that each of these little blocks are worth 20 feet, so perfect. So I go straight above here, and this is going to be my 1220. Straight above here is going to be 1240. Straight above here is 1260, and then up to here is 1280. So now I can start to draw my line. Then I would do the same thing here. So this is 1320, and this is 1340. The next 20 up, and the next 20 up here. So we see this is a little bit different because we've got steep, and then we get more gentle. And that makes a lot of sense because as we remember, we have them close together, nice and steep, and then far apart would be more gentle there. So now I see that I've got to connect the 1400 dots. And so this is where this little kind of frowny face is helpful because I know I want to make a little hilltop here. Now you don't want to get to this next 20-foot line because if you did, you would see another contour in here, but we don't. So we want to make that little rounded hilltop and don't quite get to that next line. Then we come back down in here and we'll see that we've got 3 contours going down. So let's make sure it's lined up well. Yep. So right here would be going down by 20. This one is going down by 20. This one here is going down by 20. And then we know that as we jump over here, we've got this little saddle in there. And so this one is going to stay at the same elevation. So we would go here, and then up to here, and then up to here. And so once again, we would connect that going down. We know that these go up. And we're going to draw a little saddle in. We don't want to go too deep because we don't want to hit that next elevation mark. So we're going to create that little saddle right in there. Now we've got to decide what to do with this little section in here where we have a 1400 followed by a 1400. Well, we can see I drew another little hilltop. So once again, we don't want to get to the next 20-foot line, but we want to keep that right below there. And then this is kind of nice because this is a great example of how these are pretty evenly spaced between here. So you could take the time to draw those out, but I would probably just connect these two. It isn't like one of these over here where it's steep and then gentle. They're just evenly spaced. So you can just infer that. The same thing is true here. Between 1300 and 1200, they're really evenly spaced. So I would probably just draw that straight down in there. It only really matters when there's variation in their spacing. So now as we come down, I'm going to have to drag my paper down a little bit so we can see a little bit better what we're looking at here. Okay. So let's see what we're doing. We're still going down slope and we're getting to this point here. And this spacing is a little different here. So I will take the time to go down by 20 down by 20, down by 20, and down by 20. And so this will look a little more interesting with a little bit of shape to that. And then here we have 2 that go down. So I'm going to go down and down, 20 and 20. I know I've got a little saddle again, and I'm going to go up and up. So I'm going to come here and here. And remember that these are going down, these are going up, but these 2 ticks in here are going to be the same elevation, right? Because that's where the saddle is. So if you have to mark those with values, that might make sense to you. Or if I see that little saddle mark, I'm like, oh, okay. So we didn't get down to the next one, so these 2 must be at the same elevation. So once again, I would connect these and come back up. I've got another little hilltop, same logic as before. And then I'm going to go down here. So down by 20, down by 20, and then this is the end of the profile there, so I would just bring it right to there. Oops, right to there. There we go. And so I made a little mistake there because I originally, when I drew it, I passed that next contour indicator line, right? But I wouldn't want to do that because I didn't make another tick mark on there. So I would want to make it go off before I hit that next horizontal line there. So now we have our profile drawn. It looks pretty good. You get an idea of what that looks like. So now we need to look at what's called vertical exaggeration. And to do that, we want to determine how much horizontal distance is represented across that A to A prime line and how much vertical distance is represented across this vertical line. So let's first talk about the map. So if you get out a ruler, what you can do is you can measure the distance across this line. And we're going to see that it's about 4.5 inches. So what I would say is, let me move this over a little bit so you can see. The way I would work through this is say, okay, 4.5 inches on map equals, and I have to think about what does that actually equal? Well, it tells me here that this is a 1 to 24,000 scale map, which means that 1 inch would be 24,000 inches in real life. So 4.5 inches would be 4.5 times 24,000. So if I do the math on that, it works out to 108,000 inches in real life. So we know if you were to walk along the A to A prime line in real life, you would walk 108,000 inches. And so let's convert that to feet. And so we know there are 12 inches in 1 foot. So we would take 108,000, divide that by 12, and that would get us 9,000 feet in real life. So once again, if you walked across that line, you would walk, at least horizontally, 9,000 feet. So that covers what's happening across here. So this would be 9,000 feet. There. All right, so let's take a look at what's happening vertically. And if we were to measure this, once again, we actually see that this is 1 inch. So 1 inch equals, this would be 1,000, right? Because each of these is 100. So 1 inch vertically is going to equal 200 feet. So 1 inch on graph equals 200 feet in real life. Oops, life. And remember, this we're talking about horizontal distance across the map. Here we're talking vertically on our graph there. So if we know that 1 inch on the graph is 200 feet, so I can do that here. So this is 200 feet. It's going to be really helpful to know what 1 inch across here represents. So if we know that 9,000 feet is 4.5 inches, what we really want to know is what 1 inch equals. So we would want to measure across here There's our 1 inch mark. So that's 1 inch. So how many feet is that? If I take 9,000 feet and divide it by 4.5, what I'm going to get is 2,000 feet. So 2,000 feet equals 1 inch here, right? And 9,000 is 4.5 inches. So now I can see that while 1 inch vertically is 200 feet, 1 inch horizontally is 2,000 feet. So to calculate vertical exaggeration, what I want to do is I want to take the amount of feet across here on the bottom, that's 1 inch, so 2,000 feet, and divide it by what 1 inch is represented horizontally, so 200 feet. And so if I divide that out, I get a 10. And so this is a 10 times factor. So it's stretched by a factor of 10. So we would need to reduce this quite a bit to get the actual feel for what the landscape would look like. So this is called vertical exaggeration.